today what we're going to do is we're going to be solving equations that use radicals. And basically there's kind of two things to kind of keep in mind. That if I have a square root, what will cancel that out is a square. Because if you remember to what a radical really is, it's a fraction. That's 1, that's 2, so it's a half. And so what would get rid of that half? Well, when you multiply, it would be a 2. So 2 over 1, that would cancel out. So the square cancels the square root. So that's what we'll do in order to get to our variable. The second thing that you'll want to remember is that you'll want to isolate your square root sign. Okay, so you want to make sure it's by itself on one side of the equation. So let's take a look at this one. Square root of 5x plus 1 equals 4. Again, this square root blocks the 5x1, so I need to get rid of the square root before I can get to the 5x. And I do that by squaring, and I have to do it to both sides. Now, even though it's a binomial underneath, the square simply cancels out the 5x, or the square root. So I don't need to do any FOILing, it just cancels the radical. And I get my answer. I'm going to subtract 1. 5x equals 15. And then finally, x equals 3. In example number 2, I have the square root of 5x plus 3 plus 2 equals 0. And again, like I mentioned, you want to isolate the square root before you do any squaring. So what I'll do is I'll subtract 2 from both sides, and I'll get the square root of 5x plus 3 equals negative 2. Again, to cancel out the square root, I square both sides, and I'm left with 5x plus 3 equals 4. I subtract 3 and get 1/5. In example number 3, you'll notice that we do have one radical on one side of the equation by itself, but then we have a binomial on the other side. So when I go to square both sides, the 5 minus x does cancel out the radical, but because I'm squaring a binomial, I'm actually FOILing. So you'll get x squared plus 2x plus 1. I'll have to combine like terms, so I'm going to add x, subtract 5, and get 0 equals x squared plus 3x minus 4. And I'm going to see if it will factor. If it doesn't factor, I'll have to use the quadratic formula or completing the square. But we're lucky that this one does. And then I set each to 0 and get negative 4 and positive 1. And we actually get 2 solutions for this. Alright, and our last example for the day is going to be example number 4. You'll notice this one is different because it has 2 square roots in it. So what we're going to do is we're still going to try to isolate one of the radicals, so we'll bring this over to the other side. We'll have the square root of 2x plus 3 equals 1 minus square root of x plus 1. I'll square both sides, and we'll get 2x plus 3 equals, and because this is a binomial, I am going to have to FOIL it. So we'll have to FOIL this out, and we'll get 1 minus square root of x plus 1 minus square root of x plus 1 plus x plus 1. Because square root of x plus 1 times square root of x plus 1 actually cancels itself out. So I'll simplify now. I will bring over my numbers over to the other side, so it's really minus 2. So 2x plus 1 equals negative 2 square root of x plus 1. And technically I say you have to isolate it, but if you have a coefficient in the front, that's fine. Just make sure you remember to square it, because again, I want to get rid of that radical to get to my variables. So I'm going to square this again. 4x squared plus 4x plus 1. And then because I'm squaring each of these, this is going to be 4 times quantity x plus 1. I'll distribute 4x squared plus 4x plus 1 equals 4x plus 4. Our 4x's cancel out. And I get 4x squared 0. And I can just solve this by isolating the x and get 4x squared equals 3. Divide by 4. Take the square root of my x squared. And because I'm taking the square root of a square, it's going to be plus or minus square root of 3 over 2 is my final answer.